What is dark matter? Roughly 80% of the mass of the universe is made up of material that scientists cannot directly observe. Known as dark matter, this bizarre ingredient does not emit light or energy. So why do scientists think it dominates? Since at least the 1920s, astronomers have hypothesized that the universe contains more matter than seen by the naked eye. Support for dark matter has grown since then, and although no solid direct evidence of dark matter has been detected, there have been strong possibilities in recent years. Motions of the stars tell you how much matter there is, Peter Van Dokkum, a researcher at Yale University, said in a statement. They don't care what form the matter is, they just tell you that it's there. Van Dokkum led a team that identified the galaxy Dragonfly 44, which is composed almost entirely of dark matter. Familiar material of the universe, known as baryonic matter, is composed of protons, neutrons and electrons. Dark matter may be made of baryonic or non-baryonic matter. To hold the elements of the universe together, dark matter must make up approximately 80% of the universe. The missing matter could simply be more challenging to detect, made up of regular, baryonic matter. Potential candidates include dim brown dwarfs, white dwarfs and neutron stars. Supermassive black holes could also be part of the difference. But these hard-to-spot objects would have to play a more dominant role than scientists have observed to make up the missing mass, while other elements suggest that dark matter is more exotic. Most scientists think that dark matter is composed of non-baryonic matter. The lead candidate, WIMPs, weakly interacting massive particles, have 10 to 100 times the mass of a proton, but their weak interactions with normal matter make them difficult to detect. Neutralinos, massive hypothetical particles heavier and slower than neutrinos, are the foremost candidate, though they have yet to be spotted. Sterile neutrinos are another candidate. Neutrinos are particles that don't make up regular matter. A river of neutrinos streams from the sun, but because they rarely interact with normal matter, they pass through the Earth and its inhabitants. There are 3 known types of neutrinos. A fourth, the sterile neutrino, is proposed as a dark matter candidate. The sterile neutrino would only interact with regular matter through gravity. One of the outstanding questions is whether there is a pattern to the fractions that go into each neutrino species. Thijs de Jong, an associate professor of physics and astronomy at Michigan State University and a collaborator on the IceCube experiment. Smaller neutral axion and the uncharged photons, both theoretical particles, are also potential placeholders for dark matter. According to a statement by the Gran Sasso National Laboratory in Italy, LNGS, several astronomical measurements have corroborated the existence of dark matter, leading to a worldwide effort to observe directly dark matter particle interactions with ordinary matter in extremely sensitive detectors, which would confirm its existence and shed light on its properties. However, these interactions are so feeble that they have escaped direct detection up to this point, forcing scientists to build detectors that are more and more sensitive. Or, perhaps the laws of gravity that have thus far successfully described the motion of objects within the solar system require revision. How do we know dark matter exists? If scientists can't see dark matter, how do they know it exists? Scientists calculate the mass of large objects in space by studying their motion. Astronomers examining spiral galaxies in the 1970s expected to see material in the center moving faster than on the outer edges. Instead, they found the stars in both locations traveled at the same velocity, indicating the galaxies contained more mass than could be seen. Studies of the gas within elliptical galaxies also indicated a need for more mass than found in visible objects. Clusters of galaxies would fly apart if the only mass they contained were visible to conventional astronomical measurements. Albert Einstein showed that massive objects in the universe bend and distort light, allowing them to be used as lenses. By studying how light is distorted by galaxy clusters, astronomers have been able to create a map of dark matter in the universe. All of these methods provide a strong indication that most of the matter in the universe is something yet unseen. Dark matter research. Although dark matter is different from ordinary matter, there are a number of experiments working to detect the unusual material. The Alpha Magnetic Spectrometer (AMS), a sensitive particle detector on the International Space Station, has been operating since its installation in 2011. So far, AMS has tracked more than 100 billion cosmic ray hits in its detectors. AMS lead scientist Samuel Ting, a Nobel laureate with the Massachusetts Institute of Technology, told Space.com. "We have measured an excess of positrons, the antimatter counterpart to an electron, and this excess can come from dark matter. But at this moment, we still need more data to make sure it is from dark matter and not from some strange astrophysics sources," Ting said. "That will require us to run a few more years." Back on Earth, beneath a mountain in Italy, the LNGS's XENON-1T is hunting for signs of interactions after WIMPs collide with xenon atoms. The lab recently released the first results of the experiment. A new phase in the race to detect dark matter with ultra-low background massive detectors on Earth has just began with XENON-1T, project spokesperson Elena Aprile, a professor at Columbia University, said in a statement. "We are proud to be at the forefront of the race with this amazing detector, the first of its kind." The large underground xenon dark matter experiment LUX, seated in a gold mine in South Dakota, has also been hunting for signs of WIMP and xenon interactions. But so far, the instrument hasn't revealed the mysterious matter. A positive signal would have been welcome, nature was not so kind. Chom Gog, a physicist at University College London and collaborator on LUX, said in a statement. Nonetheless, a null result is significant as it changes the landscape of the field by constraining models for what dark matter could be beyond anything that existed previously. IceCube Neutrino Observatory, an experiment buried under Antarctica's ice, is hunting for sterile neutrinos. Sterile neutrinos only interact with regular matter through gravity, making it a strong candidate for dark matter. Other instruments are hunting for the effects of dark matter. The European Space Agency's Planck spacecraft has been building a map of the universe since it was launched in 2009. By observing how the mass of the universe interacts, the spacecraft can investigate both dark matter and its partner, dark energy. In 2014, NASA's Fermi Gamma Ray Space Telescope made maps of the heart of the Milky Way in gamma-ray light, revealing an excess of gamma-ray emissions extending from its core. The signal we find cannot be explained by currently proposed alternatives and is in close agreement with the predictions of very simple dark matter models, lead author Dan Hooper, an astrophysicist at Fermilab in Illinois, told Space.com. The excess can be explained by annihilations of dark matter particles with a mass between 31 and 40 billion electron volts, researchers said. The result by itself isn't enough to be considered a smoking gun for dark matter. Additional data from other observing projects or direct detection experiments would be required to validate the interpretation. Astronomers know more about what dark matter is not than what it actually is. Image credit, Carl Tate, Space.com infographics artist. Dark matter versus dark energy. Although dark matter makes up most of the matter of the universe, it only makes up about a quarter of the universe's total composition. The energy of the universe is dominated by dark energy. After the Big Bang, the universe began expanding outward. Scientists once thought that it would eventually run out of energy, slowing down as gravity pulled the objects inside it together. But studies of distant supernovae revealed that the universe today is expanding faster than it was in the past, not slower, indicating that the expansion is accelerating. This would only be possible if the universe contained enough energy to overcome gravity, dark energy.